Imagine a time before time itself. No stars, no galaxies, no cosmic dust, just an unfathomable emptiness, or perhaps something far more mysterious. We've all heard of the Big Bang, the moment when our universe sprang into existence nearly 13.8 billion years ago. But here's the real mind-bender. What came before it? Was there a before at all? Could the universe have existed in a form we can't even begin to comprehend? This question has haunted scientists, philosophers, and dreamers alike for centuries. Today, we're diving into one of the most profound and perplexing mysteries in modern cosmology. What was the universe before the Big Bang? To truly grasp this question, we must first understand why it's so difficult to answer. The biggest challenge? The limits of our knowledge. Our entire understanding of reality is based on the framework of physics, laws and principles that govern how things work in our universe. But here's the catch. Those laws emerged with the Big Bang itself. Everything we can see, measure, or even theorize about originates from that singular moment. Before that, we hit a wall, a boundary beyond which physics, as we know it, collapses. This is called the Planck epoch, a fraction of a second after the Big Bang, when the universe was so hot, so dense and so chaotic that even our most advanced scientific theories stopped making sense. Time, space, gravity, everything was compressed into an almost incomprehensible singularity. And if time itself emerged from the Big Bang, then what does before even mean? This is where things get fascinating, because while we don't yet have a complete answer, there are some compelling theories, some that challenge everything we think we know about the nature of existence. Theory 1. The cyclic universe, a never-ending loop of creation, one of the most intriguing possibilities, is that the Big Bang wasn't the beginning at all. Instead, it may have been just one event in an endless cycle of cosmic rebirth. This idea, known as the cyclic universe, suggests that the universe undergoes infinite cycles of expansion and contraction, expanding outward, slowing down, collapsing back in on itself, and then rebirthing into another Big Bang. Imagine a cosmic heartbeat: expansion, collapse, rebirth. Forever. This concept isn't new. In fact, it has deep philosophical and scientific roots. Ancient Hindu cosmology speaks of an eternal, oscillating universe, the cycle of creation and destruction, known as the Kalpa cycles. Modern physics offers a similar perspective through models like the ekpyrotic theory, which suggests that our universe was born from the collision of vast, higher-dimensional branes in a larger, multidimensional space. These branes could periodically crash into each other, triggering new cycles of Big Bangs. If this theory holds, then what came before our Big Bang? A previous universe, and before that, another one. The cycle never stops. But if this is true, why don't we see evidence of past universes? Some scientists believe that faint imprints from previous cosmic cycles could be embedded in the cosmic microwave background radiation, CMB, the afterglow of the Big Bang. Could certain anomalies in this radiation be whispers from an older cosmos? Some physicists believe so, though the evidence is far from conclusive. Theory 2. Eternal inflation, an endless cosmic multiverse. Now, what if our Big Bang was just a small part of something vastly larger, something that has no beginning or end? That's the idea behind eternal inflation, one of the most mind-boggling concepts in modern cosmology. Here's how it works. In the earliest moments of the universe, space itself expanded at an incredible rate, much faster than the speed of light. This process, known as cosmic inflation, eventually slowed down, allowing galaxies, stars, and planets to form. But what if that inflation never completely stopped? What if instead, some regions of space continued expanding forever, forming new bubble universes all the time? In this model, our universe is just one bubble in an infinite cosmic foam, with countless other universes popping into existence, all the time. If true, this means that before our Big Bang, there was no singular beginning, only an eternal, ever-growing sea of universes, each with its own set of physical laws. Some might resemble ours, while others could be completely unrecognizable. Realities where time flows backward, where gravity repels instead of attracts, where stars burn cold instead of hot. This theory also raises another fascinating possibility. Could some of these universes interact with ours? Could the effects of a neighboring universe somehow leave imprints in our own cosmic structure? Some cosmologists believe we might someday detect subtle signs of these interactions, perhaps a gravitational tug from another universe pulling on ours. Theory 3. The universe from nothing. The quantum birth of reality. But what if, instead of coming from another universe, our universe came from nothing? It sounds absurd, but some physicists argue that nothing isn't as empty as we think. Quantum mechanics tells us that even in a perfect vacuum, tiny energy fluctuations constantly occur. These fluctuations can create pairs of particles and antiparticles, which usually annihilate each other instantly. But in rare cases, these fluctuations could trigger something much bigger, a burst of energy so intense that it creates an entire universe. If this idea is correct, then our universe may have been born from a random quantum event in a state of absolute nothingness. This idea is supported by the work of physicists like Stephen Hawking and Lawrence Krauss, who proposed that the laws of quantum physics make it possible for entire universes to spontaneously pop into existence without the need for a prior cause. But if that's the case, why did it happen? And could it happen again? Theory 4. The simulation hypothesis. Was the universe programmed? There's one more possibility, one that doesn't rely on physics at all. What if the universe was designed? Not by a god or an intelligent creator in the traditional sense, but by something else, an advanced civilization or entity beyond our understanding. The simulation hypothesis suggests that what we perceive as reality is actually a highly advanced digital simulation, much like a computer game or virtual reality program. If this is true, then the question of before the Big Bang is no longer a scientific one, but a technological one. The Big Bang wouldn't be a natural event. It would be the moment the simulation was turned on. Could there be signs that our universe is a simulation? Some scientists believe that certain mathematical structures underlying physics resemble computer code, as if reality itself is built on a set of programmed rules. If this is the case, then the true answer to what came before the Big Bang might be the moment an advanced civilization hit run on the cosmic program. But before we venture too far down that rabbit hole, we need to address another fundamental question. What happens to time itself when we go back before the Big Bang? Does time cease to exist? Or is it something far stranger than we ever imagined? What happens to time before the Big Bang? The question of what existed before the Big Bang is closely tied to something even more fundamental, the nature of time itself. We take time for granted. It flows forward, we age, events unfold in sequence. But before the Big Bang, did time even exist? And if it did, was it anything like the time we experience now? To answer this, we need to start by understanding what time actually is. You might think of it as a simple, ever-moving river carrying us from past to future, but in reality, time is deeply connected to space itself. According to Einstein's theory of general relativity, space and time are woven together into a single fabric called space-time, a dynamic, flexible entity that can stretch, bend, and warp under the influence of gravity. So here's the crucial part. If space itself was created in the Big Bang, then what does that mean for time? Did time have a beginning too? Theory 1. Time began with the Big Bang. One of the most widely accepted ideas among physicists is that time itself began with the Big Bang. This was famously proposed by Stephen Hawking, who suggested that asking what happened before the Big Bang is like asking what's north of the North Pole. The question doesn't make sense because there's no meaningful before. Time simply didn't exist. Think of it like this. If time is a dimension, just like height, width, and depth, then going back to the moment of the Big Bang would be like reaching the edge of that dimension. You can't go further because there is no further. Time is not an infinite road stretching backward. It's a finite curve that stops at the Big Bang itself. If this is true, then the question of before the Big Bang has no answer, because before is a concept that only exists after time begins. This would mean that the universe and time itself simply popped into existence with no prior cause. But does that really make sense? Can time just appear out of nowhere? This is where alternative theories come into play. Theory 2. A universe. Without a beginning, what if time didn't begin at the Big Bang but has always existed? Some physicists argue that our universe could be part of an eternal, never-ending process. In this view, the Big Bang wasn't the start of everything. It was just a transition point in an infinitely old cosmos. One version of this idea is the cyclic universe model, which we touched on earlier. But another possibility is the conformal cyclic cosmology, CCC theory, proposed by the legendary physicist Sir Roger Penrose. According to this idea, the universe goes through endless phases called aeons. After each phase of expansion and cooling, the universe effectively resets and begins a new cycle. However, the transition between these phases isn't a violent collapse, it's smooth. Here's the strange part. As the universe continues expanding over trillions upon trillions of years, all matter, stars, and black holes will eventually evaporate due to Hawking radiation, leaving behind a vast empty void. Without matter or any meaningful structure, the distinction between time and space may cease to exist. This empty universe, strangely enough, could mathematically resemble the ultra-hot, ultra-dense universe of the Big Bang, creating a loop. In other words, the end of one universe naturally gives rise to another. If Penrose's theory is correct, then time extends infinitely into both the past and the future. The Big Bang wasn't the beginning, it was just one turn of the cosmic. Wheel Theory 3, time flows backward. Before the Big Bang, here's where things get even more bizarre. What if time didn't just exist before the Big Bang, but actually flowed in reverse? This idea comes from a branch of physics called thermodynamics, which deals with entropy, the measure of disorder in a system. One of the most fundamental laws of the universe is the second law of thermodynamics, which states that entropy always increases over time. In simpler terms, the universe moves from order to disorder. A glass shatters, but the shattered pieces never spontaneously form a glass again. But what if before the Big Bang entropy was running in the opposite direction? Some scientists speculate that in the pre-Big Bang universe, time flowed in reverse, meaning that in that era, everything moved from disorder to order. If you were living in that universe, you wouldn't age, you'd grow younger. Broken objects would reassemble themselves. The arrow of time as we know it would be flipped. This idea is supported by certain solutions in Einstein's equations, which allow for two universes, one moving forward in time, ours, and one moving backward in time, a mirror universe. These two universes would exist on opposite sides of the Big Bang, expanding away from each other. If true, this would mean that both past and future exist symmetrically, and the Big Bang wasn't a beginning, just a bridge between two opposing worlds. Theory 4. A higher dimensional universe before ours. What if our universe was born from a larger, higher dimensional reality? Some physicists believe that the Big Bang could have been the result of a collision or interaction in a higher dimensional space. In string theory, our universe is thought to be a three-dimensional brain floating inside a higher dimensional space, known as the bulk. Imagine our universe as a flat sheet of paper inside a much larger multidimensional room. If another brain collided with ours in this higher dimensional space, the resulting energy release could have created the Big Bang. This theory, known as the ekpyrotic model, suggests that our universe is just one of many floating in a higher dimensional space. These brains might occasionally collide, producing Big Bang-like events, which would mean that our Big Bang was simply one event in a much larger cosmic structure. If this is correct, then before the Big Bang wasn't nothing. It was a vast, multi-dimensional space filled with other universes, interacting in ways we can't yet comprehend. Where does this leave us? As we've seen, the question of what existed before the Big Bang has no single answer, because we don't yet have a theory that fully explains the origin of the universe. Each idea we've explored, whether it's the notion that time began at the Big Bang, the possibility of an eternal cyclic universe, or the idea that our universe came from a higher dimensional space, offers a glimpse into the deepest mysteries of reality. But here's the real question. If we could somehow look beyond the Big Bang, if we could pierce the veil of that cosmic boundary, what would we see? Would we find a universe before ours, a realm of higher dimensions, or would we encounter something so alien that our minds simply couldn't comprehend it? One thing is clear: the deeper we explore, the more we realize just how little we know. And yet, with every discovery, every theory, and every new question, we inch closer to understanding the true origins of everything. But before we dive deeper, there's another pressing question we need to address. If the Big Bang wasn't the absolute beginning, could there be evidence of past universes hidden in our own cosmos? Could evidence of past universes be hiding in our own cosmos? If there was something before the Big Bang, whether it was another universe, a higher dimensional realm, or an infinite cycle of cosmic rebirth, shouldn't there be some kind of evidence left behind? Could the echoes of past universes be imprinted on our own cosmos, waiting to be discovered? This idea might sound like science fiction, but many physicists believe that traces of the pre-Big Bang era could be hidden in the cosmic microwave background radiation, CMB, the faint afterglow of the Big Bang itself. To understand why, let's take a step back and explore what the CMB actually is. The oldest light in the universe, a cosmic fingerprint, the CMB is the oldest observable light in the universe, dating back to around 380,000 years after the Big Bang. Before this time, the universe was a dense, hot plasma where light couldn't escape. But as the universe expanded and cooled, atoms formed, allowing photons to travel freely for the first time, creating the CMB. Today, this ancient light has stretched into microwave wavelengths due to the expansion of the universe. It fills all of space as a nearly uniform background glow. But here's the key. This glow isn't perfectly smooth. Tiny fluctuations in temperature, mere fractions of a degree, are scattered across the sky, providing a snapshot of the universe's early structure. And some physicists believe these fluctuations might hold clues about what happened before our universe began. Circular patterns in the CMB, echoes of a past universe. One of the most intriguing ideas comes from Sir Roger Penrose, the physicist behind conformal cyclic cosmology, CCC. Penrose argues that our universe is just one in an infinite sequence of cosmic aeons, and that imprints of previous universes might be visible in the CMB. How? He predicts that massive black holes from past universes could have left behind circular patterns in the cosmic microwave background. According to his theory, when a universe reaches its final stage, trillions of years into the future, all matter, including black holes, eventually evaporates. But instead of vanishing completely, the energy from these ancient black holes might have rippled through time into the next universe, appearing as subtle, concentric circles in the CMB. And here's where things get even more intriguing. When astronomers actually searched for these patterns, they found something strange. Multiple studies have reported unexplained circular temperature variations in the CMB, exactly the kind of imprint that CCC predicts. Could this be the first direct evidence that a universe existed before ours? Or is there another explanation? The mystery of the cold spot, a window into another reality. There's another peculiar anomaly in the CMB that has baffled scientists for years, something called the cold spot. Located in the constellation Eridanus, the cold spot is an unusually large region of space where the CMB temperature is much lower than expected. Scientists have proposed several explanations for this anomaly, including a massive cosmic void, an empty region of space with fewer galaxies than normal. But some researchers have suggested something far more radical. What if the cold spot is a scar left behind by another universe? According to theories inspired by string theory and the multiverse hypothesis, our universe might be just one of many floating in a vast, higher dimensional space. If another universe collided with ours in the distant past, it could have left an imprint on the CMB, possibly explaining the cold spot. This raises an even more profound question. Could our universe still be interacting with other universes right now? Could we detect other universes? The idea that we live in a multiverse, an infinite collection of parallel universes, has gained traction in modern physics. Some theories suggest that other universes might exist just beyond the limits of our observable cosmos, forever hidden from view. But what if there was a way to detect them? One possibility is that universes in the multiverse might sometimes collide or interact. If so, their gravitational influence could cause subtle distortions in the cosmic fabric of our own universe, distortions that might be detectable. In fact, some physicists are looking for unusual gravitational wave signals that could hint at cosmic collisions between universes. If such a signal were found, it would be one of the most groundbreaking discoveries in history, offering direct evidence that our universe isn't alone. Another approach involves studying high-energy particles called ultra-high-energy cosmic rays. These mysterious particles strike Earth from deep space with energies far beyond anything human technology can produce. Some scientists speculate that they could be leaking into our universe from a parallel cosmos, providing indirect evidence of other realities. What about quantum physics? Does it hint at other universes? If our universe came from something before the Big Bang, could quantum physics hold the key to unlocking its secrets? Quantum mechanics, the strange science of the very small, tells us that particles can exist in multiple states at once, only choosing an outcome when observed. This bizarre property has led some physicists to propose the many worlds interpretation, which suggests that every quantum event creates multiple parallel realities. If this is true, then the universe didn't just emerge from one Big Bang. It could have split into countless parallel timelines, each with its own version of history. This means that there might be other versions of you living entirely different lives in alternate universes. While this interpretation remains highly controversial, it raises an exciting possibility. If quantum mechanics allows for many worlds, could the birth of our universe itself have been a quantum event? Could the Big Bang be just one of an infinite series of branching realities? The search continues. For now, we are left with more questions than answers. The circular imprints in the CMB, the eerie cold spot, the possibility of cosmic collisions, and the weirdness of quantum mechanics all point towards something profound. Our universe may be far stranger than we ever imagined, but the journey to uncover the truth isn't over. Scientists are now using advanced telescopes, deep space surveys, and quantum experiments to probe deeper into the fabric of reality. Future discoveries, perhaps from the James Webb Space Telescope, new gravitational wave observatories, or experiments in quantum computing, could bring us closer to understanding what, if anything, existed before our universe. And if we do find proof of something before the Big Bang, it would change everything we thought we knew about the cosmos. But this leads to an even bigger question. If the universe had a cause, what caused the cause? Could something exist beyond even time itself? What caused the cause? The ultimate question of existence. If our universe had a beginning, then it's natural to ask what caused it. And if something existed before the Big Bang, whether it was a previous universe, a quantum fluctuation, or a timeless reality, what caused that? This question pushes the limits of human reasoning. At some point, do we reach a final answer, or does the chain of causes go on forever? There are three main possibilities that scientists and philosophers consider: an infinite chain of universes, eternal cycles, or the multiverse; a self-creating universe, spontaneous creation from quantum mechanics; a fundamental, timeless reality, a final answer beyond time. Let's explore each of these mind-bending ideas. The universe as an eternal cycle. No beginning, no end. One way to avoid the problem of an ultimate cause is to argue that the universe never truly had a beginning at all. Instead, it could be part of an infinite cycle, where each Big Bang is simply the rebirth of the cosmos. This idea has appeared in various forms throughout history. In Hindu cosmology, the universe is said to go through endless cycles of creation and destruction, much like the cyclic models proposed in modern physics. We've already discussed conformal cyclic cosmology, CCC, where universes repeat indefinitely, leaving traces of their past selves in the cosmic microwave background. But there's another version of this idea, the Big Bounce. According to the Big Bounce hypothesis, the universe didn't start from a singularity, but rather from the collapse of a previous universe. Instead of an absolute beginning, space and time might contract and expand in an infinite loop. Recent theories suggest that quantum effects, especially those involving dark energy, could prevent a complete collapse, allowing the universe to bounce into a new expansion. If this is true, then the Big Bang was simply the latest bounce in a never-ending sequence. But even if this model is correct, the question remains, where did the first universe in the cycle come from? Was there ever a first universe, or has existence always been? Could the universe have created itself? Another radical possibility is that our universe created itself out of nothing. At first, this sounds impossible. How can something come from nothing? But in the strange world of quantum physics, nothing isn't truly empty. It's a seething ocean of virtual particles and energy fluctuations. According to quantum mechanics, tiny particles constantly pop in and out of existence in the vacuum of space. Normally, these fluctuations are tiny and short-lived, but what if, under the right conditions, a whole universe could emerge? This idea, known as spontaneous creation, is supported by some interpretations of quantum gravity. The famous physicist Stephen Hawking argued that the laws of physics allow universes to form naturally, without needing a divine creator or an external cause. In this model, space and time themselves might be products of quantum fluctuations. The universe could have emerged from a timeless quantum state, where time itself was an illusion. But even if this is possible, where did the laws of physics come from? Did they exist before the universe, or are they part of reality itself? Is time an illusion? Could reality be deeper than the universe? One of the most mind-blowing ideas in modern physics is that time itself might not be fundamental. We experience reality as a sequence of events, past, present, and future. But some theories suggest that time is just a human perception, and that the universe exists as a timeless whole, where everything already exists in a higher dimensional reality. This idea is supported by relativity, which shows that time flows differently depending on gravity and motion. If time is relative and not absolute, could it be that the universe exists in a block of space-time, where all events, past, present, and future, already exist? If true, then the Big Bang wasn't the beginning of time. It was just another coordinate in a timeless reality. Some physicists, like Julian Barber, argue that the flow of time is an illusion created by change. In this view, the universe isn't moving through time, it just exists. If this is true, then the question, what came before the Big Bang, might not even make sense, because before is a meaningless concept in a timeless universe. The search for the ultimate reality, this leads to the deepest question of all. Is there a final reality beyond the universe? Some physicists speculate that our universe is just a lower dimensional shadow of a higher dimensional reality. String theory suggests that extra dimensions exist beyond our perception, and some interpretations propose that the true nature of existence lies in a hyperdimensional realm that we can barely comprehend. Others propose that the universe is a mathematical structure, an abstract reality where physical laws emerge from pure logic and geometry. And then there's the most extreme possibility, that consciousness itself is fundamental and the universe is a product of observation. Some interpretations of quantum mechanics suggest that reality only becomes real when observed, raising the possibility that consciousness plays a direct role in shaping the cosmos. Could the true nature of reality be beyond physics itself? Are we part of a larger cosmic intelligence, or is the universe simply the result of mindless mathematical laws playing out in an infinite loop? What if we find the answer? If science ever finds a definitive answer to what existed before the Big Bang, whether it's an eternal cycle, a quantum fluctuation, or something beyond time, it would change everything. It would redefine our place in the cosmos, our understanding of existence, and possibly even the fate of the universe itself. But perhaps the ultimate truth is forever beyond our reach. Maybe the nature of reality is so complex that we will always be one step away from the final answer. Or maybe, just maybe the truth is already in front of us, we just haven't learned how to see it yet. After all the theories, all the possibilities, and all the scientific debates, we are left with a question so profound that it may never have a final answer. What existed before the Big Bang? Was there a time before time? Was there a universe before our universe? Or was the very concept of before meaningless in the grand scheme of reality? The deeper we look into the cosmos, the more we realize that our understanding is still in its infancy. Every discovery leads to more questions. Was the universe part of an endless cycle? Did it emerge from a quantum fluctuation? Is time itself an illusion? Or is there a hidden reality beyond space and time that we may never grasp? Perhaps the true nature of existence is something beyond our comprehension, something that transcends the limitations of human thought. Maybe the answer lies in physics yet to be discovered, or maybe it's been right in front of us all along, waiting for us to see it in a way we never imagined. But one thing is certain, the journey to uncovering the origins of our universe is far from over. Each new discovery brings us closer to understanding not only where we came from, but also what our place in the cosmos truly means. What do you think? Is the Big Bang the true beginning, or is there something even greater beyond it? Share your thoughts in the comments below. And if you enjoyed this deep dive into the biggest mystery of all, don't forget to like, share, and subscribe to Cosmic Whispers, because the universe is vast and we've only just begun exploring its secrets.